Types and functions of rails. At the end of this lesson, you will be able to define a rail, explain the functions and types of rails, describe the defects in rails. A family is happy and content when its individuals are supportive of each other. Parents who are understanding and supportive of each other set up a perfect example for the children to follow. Similarly, the rails of a railway track work together for the proper functioning of railways. If one rail is broken or defective or misaligned, it may lead to railway accidents. Thus, it is clear that rails serve as the main element for the proper functioning of the railways. In this lesson, we shall be learning the functions and types of rails in detail. Rails are the components of a railway track, which are laid in two parallel lines. These two rails are separated by a definite distance called as the gauge. They provide a clear cover between the wheelbase and the sleeper ballast layer by uplifting the train from the ground level. The cross-section of a rail resembles an I shape with three components, namely the head, the web, and the base. The top portion of the rail is the head. It helps to take up the impact of the fast-moving wheels. The bottom flat portion is the base or the foot. It helps in clamping the rail to the sleeper as well as in transferring the train loads. The middle portion of a rail is the web. It provides the necessary stiffness to the entire rail section. In addition to the stated individual functions, the rails perform the following functions in general. They serve as a lateral guide for the movement of train wheels by providing a leveled and continuous surface. They also provide a smooth pathway with very little friction. Rails receive the loads from the train wheels and transmit them safely to a larger area of formation through the sleepers and ballasts. In addition, they bear the stress transmitted through the axles and wheels and also bear the braking and thermal forces. Rails are used to conduct electric current to a track circuit signaling system for detecting the presence of a train on the given section of the track. In order to fulfill the functions effectively, the rails must possess the following qualities. Besides the very high axle loads, the rails also experience the dynamic effect of the moving wheels. Hence, to resist these loads, the rails must possess high strength and must be of good quality. At the curves, along with the wheel loads, the rails also experience lateral forces, which can rip a rail line apart. Hence, a rail should have an adequate lateral stiffness to resist these forces. Further, the thickness of the rails decreases upon constant rubbing and pounding of wheels. To balance this, the rails must have sufficient thickness and wear resistance. Similarly, the rails must have adequate depth to manage wear in the vertical direction. Finally, the width of the rail head should be sufficient enough to accommodate the wheel flange and safely distribute the loads downwards. Now, let's discuss the various types of rails used in the construction of railway tracks. Based on the shape, the rails are classified as double-headed rails, bull-headed rails, and flat-footed rails. The rail section whose head and foot are of same dimension is called as double-headed or dumbbell rail. These rails were widely used in olden days, believing that if the rail head gets worn out, the rails could be inverted and reused. But it was later found wrong because along with the head, the foot also got corrugated under the impact of the wheel loads. Currently, double-headed rails are obsolete. To overcome the defect experienced in a double-headed rail, an improvement was made by making the head larger than the foot. These rails are known by the name bull-headed rails. Both the double-headed and the bull-headed rails rest on chairs for holding them in position and spread the load to the sleepers. A bull-headed rail offers a better alignment, solid track, and a smooth ride than a flat-footed rail. The rail sections having their foot rolled to flat are called as flat-footed rails. Flat-footed rails are fixed to the sleepers using a bearing plate. Here, no chairs are required to hold the rails in position. Thus, they require less number of fastenings and are predominantly used nowadays. Before concluding, let us discuss the defects of rails. In spite of using high-quality steel and constantly maintaining the rails, there are some extreme cases which necessitate their removal. At some sections, the rail gets hogged, which subsequently yields the formation and loosens the fastenings. This hogging greatly affects the quality of a track and demands an immediate replacement. Due to the constant movement of the trains, the metals on the rail surface get chipped out, resulting in the formation of elliptical depressions. This defect is called as scabbing of rails. If left unnoticed, these depressions progresses leading to the fracture of rails. Generally, when a train climbs a steep gradient or is subjected to the constant application of brakes, heat is produced in its wheels. This heat forms depressions on the rails called as the wheel burns, which reduce the longevity of the rails. Besides this, minute depressions are also formed on the rail surface at irregular intervals, called as corrugations of rails. These corrugations are formed by various factors such as train operations, metallurgy, the age of rails, environmental conditions, presence of sand, etc. They loosen the keys and fittings, produce unpleasant noise, and disturb the packing of rail track structure. Majority of the track failures and derailments originate due to the defects in the rails. According to the degree of defect, a part of the rail or the whole rail is either removed or replaced. Thus, the safety of trains is ensured by using good quality rails and frequent monitoring and maintenance of tracks. Summary: rails are the components of a railway track, which provides a clear cover between the wheelbase and the sleeper ballast layer by uplifting the train from the ground level. Rails act as a lateral guide for the movement of train wheels. They provide a smooth pathway with very little friction. Rails safely transfer the loads to the larger formation area. Based on the shape, the rails are classified as double-headed rails, bull-headed rails, and flat-footed rails.